Problems with MRP systems. Integrity of the data. If there are any errors in the inventory data, the bill of materials, commonly referred to as BOM data, or the master production schedule, then the output data will also be incorrect. GIGO, or garbage in, garbage out. Data integrity is also affected by inaccurate cycle count adjustments, mistakes in receiving input and shipping output, scrap not reported, waste, damage, box count errors, supplier container count errors, production reporting errors, and system issues. Many of these types of errors can be minimized by implementing pull systems and using barcode scanning. Most vendors in this type of system recommend at least 99% data integrity for the system to give useful result. 2. Systems requires that the user specify how long it will take a factory to make a product from its component parts, assuming they are all available. Additionally, the system design also assumes that this lead time in manufacturing will be the same each time the item is made, without regard to quantity being made or other items being made simultaneously in the factory. 3. A manufacturer may have factories in different cities or even countries. It is not good for an MRP system to say that we do not need to order some materials because we have plenty of it thousands of miles away. The overall ERP system needs to be able to organize inventory and needs by individual factory and intercommunicate the needs in order to enable each factory to redistribute components to serve the overall enterprise. This means that other systems in the enterprise need to work properly both before implementing an MRP system and in the future. For example, systems like variety reduction engineering, which makes sure that product comes out right first time without defects, must be in place. 4. Production may be in progress for some part whose design is changed, with customer orders in the system for both the old design and the new one concurrently. The overall ERP system needs to have a system of coding parts such that the MRP will correctly calculate needs and tracking for both versions. Parts must be booked into and out of stores more regularly than the MRP calculation takes place. Note, this order system can well be manual systems but must interface to the MRP. For example, a walk-around stock intake done just prior to the MRP calculation can be a practical solution for a small inventory, especially if it is an open store. Number 5. The other major drawback of MRP is that it fails to account for capacity in its calculations. This means it will give results that are impossible to implement due to manpower, machine, or supplier capacity constraints. However, this is largely dealt with by MRP2. Generally, MRP2 refers to a system with integrated financials. An MRP2 system can include finite or infinite capacity planning. Nevertheless, to be considered a true MRP2 system must also include financials. In the MRP2 or MRP2 concept, fluctuation in forecast data are taken into account by including simulation of the master production schedule, this creating a long-term control. A more general features of MRP2 is its extension to purchasing, to marketing, and to finance. Integration of all the functions of the company ERP has been the next step. Solutions to data integrity issues. 1. Bill of materials. The best practice is to physically verify the bill of materials either at the production site or by disassembling the product. 2. Cycle count. The best practice is to determine why a cycle count that increased or decreased inventory has occurred. Find the root cause and correct the problem from occurring again. 3. Scrap reporting. This can be the most difficult area to maintain within integrity. Start with isolating the scrap by providing scrap bins at the production site and then record the scrap from the bins on a daily basis. One benefit of reviewing the scrap on site is that the engineering group can take preventive action. 4. Receiving errors. Manual systems of recording what has been received are error prone. The best practice is to implement the system of receiving by ASN from the supplier. The supplier sends an ASN or advanced shipping notification. When the components are received into the facility, the ASN is processed and then company labels are created for each line item. The labels are affixed to each container and then scanned into the MRP system. Extra labels reveal a shortage from the shipment and too few labels reveal an overshipment. Some companies pay for ASN by reducing the time in processing accounts payable. 5. Shipping errors. The container labels are printed from the shipper. The labels are affixed to the containers in a staging area or when they are loaded on the transport. 6. Production reporting. The best practice is to use barcode scanning to enter production into inventory. A product that is rejected should be moved to an MRB or Material Review Board location. Containers that require sorting need to be received in reverse. And last, replenishment. The best replenishment practice is replacement using barcode scanning or via pull system depending upon the complexity of the product. Planners can actually order materials using scanning with a min-max system.